think we're live. And we are live. Whew. Okay, cool. Hi everyone. I think we're live. I think it is time for me to go live. So hi everyone. My name is Zach and I'm an open source developer, and I usually do quite a lot of embedded development, and I usually do quite a lot of like FPGA development. However, today we're going to explore some host application development. This is to do with connecting some USB application to a host later that we are building. So here's the thing. What I'm gonna do is I'm going to try. I only have an hour to do this today. So what I'm going to do is I'm going to try and squeeze in a quick build of a host application that we can use from one of the samples. And basically we're going to do it line by line and see if we can squeeze in a quick build and see if we can learn anything. And we can use this as sort of an introduction into USB. The first thing I want to do is actually build a USB CDC sample, and then we'll come. Let's first of all discover what CDC is, and then we can come back and build a CDC sample so that we have a CDC device. And then on top of that, we're going to build USB host CDC application to talk to the CDC application device that we've kind of built. Most of this is already done. We're just patching stuff up together and understanding what happens. And this we can use this as sort of like an excuse to start our USB USB journey. Basically, we're going to do a lot of USB development in the next month or so, and it'll be good to kind of connect. So cool. Just getting the general information out of the way. There's a link to our community, a Discord community, in the description of the video. Join our community if you want. If you want to support my work, if you want me to do more of this, there's a GitHub sponsors link in the description. You can sponsor my work. And I can buy devices, I can buy coffee, and I can pay for the internet in the office and whatever, and we can do this stuff better. And I'm gonna do some light here so that it's better. Okay, so let's discover what USB CDC is first. So USB devices, whenever you plug in like a mouse or a flash drive or something like a hard drive into USB on your phone or a webcam, you have a class, and this class is a device class that tells the host, which is your computer, what to do with that device itself. And today what we're gonna work with is a USB communications device class. And this is it's mostly common use for networking stuff. It's basically used for transferring large amounts of data. So it has something called like a bulk endpoint, and it has like an isochronous endpoint. It has a few endpoints. USB has a few endpoints basically in a device. And usually endpoint 0 is the first endpoint is a control endpoint that describes what the device is and how to use the device. So today what we're going to be working on really is the communications device class. And devices of this class are also implemented in embedded systems such as mobile phones, so that a phone might be used as a modem or a network port, and the data interfaces are generally used to perform bulk data transfer. So the first thing we want to do is, and also this is kind of linked into the abstract control model, which is a protocol for sending data between the device and the host. So the first thing we're going to do today is we're going to try and build our actual CDC application. And the easiest way of doing this, if you know me from any other of my streams, I usually work on Zephyr quite a bit. So we're going to take a USB CDC Zephyr sample, build it, put it on a device. The device in question today we're going to use is the STM32N6 application board. So we're going to make this a USB CDC application, and then we're going to connect it and see how it enumerates. Then we're going to jump into starting to build an actual, an actual host application that talks to that CDC application. So let's actually build a device there. So I'm going to close all of this stuff. As you can see, I've been doing some experimentation, and that's work stuff, and then I'll do that, and then here And then I'm gonna do deactivate so I can leave that workspace, and then cd. I'm going to Zephyr project, and then I'm gonna source something like vn bin activate. So let's make this active, and then in here I'm going to do control R west build dash b nucleo. So cool, I'm gonna do that one, and then subsys, I think this is subsys USB CDC-ACM. Okay, so let's do a CDC-ACM. I think this is going to be an echo application, so I'll do dash p, so it just okay, sorry, dash p. So let's okay, cd Zephyr. Okay, cool. And then let's clear that. Let's clear. Okay, cool. Then let's go back and actually build this application. Let's build a CDC application, and I think this one is just an echo, an echo application. I need a USB cable. And while that is building, let's open a new place and then go sudo dmesh -w, and I think let's actually just do that. Let's start that's gonna be wrong. Okay, cool. So yeah, this has a USB ACM class. We're not gonna look at that one right now. So we're going to wait until we build something, and once we build it and flash it, then we're gonna put this. We're gonna plug the USB, the device USB into. So right now we're just. We're gonna let me put this thing in bootloader mode, and then that should have actually enumerated something else, but it's not. And then I'm gonna go west flash. So we're gonna flash that, and the next thing we're going to do is actually go back and put the application on. And does anything change? Nothing changes. So now let's actually plug in the microcontroller's USB and see what actually happens. Microcontroller's USB, and then plug it into the USB port on our computer, and let's see. Aha! So you see USB-D CDC-ACM sample, and it is enumerated, and it should tell me where it is. ACM1. Okay, cool. So let's actually look. As I expect, this is something like an echo thing. It's probably like an echo device. Let's actually do that. Picocom device that. Shift D, Picocom, Picocom dev TTY ACM1. Oh, whoa. So why is that not working? Picocom dash help. Can I select a device? Am I allowed to select a device? Picocom dash device dash database board. Does it want me to select a device or something? Screen sudo apt install screen. It's fine. Let's see. Yeah. Let's try with screen. Okay, yeah. Screen dev tty ACM1 y. Control Shift T. Screen. Okay, let's check the logs. Picocom dash b dev tty ACM0 invalid baud 0. This is 11.5.200. Okay, cool. So I'm gonna reset this device, see what happens. So it's booted. USB-D, a USB device waiting for USB device support enabled, waiting for DTR, device suspended, bus reset, baud rate 9600. So what then should we do there? That's very minicom sudo apt install minicom. I don't have that much time, so let's see. Yeah, I wonder why that's actually working as such, but let's just use the devices they have and we can actually so minicom dash device, and then we can do dev CDC-ACM1 permission denied. Okay, cool. So let's go back to sudo let's actually go back to that, control A, and then sudo, I don't know why I never, no time entry for that. Let's just use a terminal, okay, and then we'll see minicom dash device dev tty-acm1, cannot open that, and control A, sudo. Okay, cool. So this works. It works. So I don't know. I think ghosty is a problem. That's fine. And if I think I do that, it does that. And then if I do B, it does that. And then if I do C, it does that. And if I do D, it does that. And then if I do Q, it does that. And then yeah. So basically it echoes control A, control Z, control A, control X. How do you exiting minicom? So I can just do that and it will die. Okay. I think A, yeah, you see. B, C. So it echoes back. It just echoes back the whatever character you sent to it. So now let's actually do some work. Eng documents eng dir USB experiment USB CDC host experiment, and then let's actually see this USB CDC. Okay, so in here let's actually make let's make us a product that talks to the application that we want to do. So the thing we're going to use today to actually speak to this application is we're going to work with libUSB. And libUSB is a C library that provides generic access to USB devices, and it's intended to be used by developers to facilitate the production of applications that speak to USB hardware. And this is now from the host side. Okay, so we're going to try and make an application using libUSB that actually enables us to speak to the USB hardware that we just plugged in. So that's cool. So touch my host, my CDC host. See, okay, and so there's that. So let's jump into this. So the first thing we need to do is probably do some sort of a couple of few includes, and then we can go from there. It should be quite simple if I remember correctly, but I might make some mistakes, and we will actually have to go refer to stuff. So instd.h, I think so. Yeah, it's that one, and then I'll include stdlib, stdlib.h, that's fine, and then I will include I think stdio, so that we can talk to the terminal, and then also what include let's say error no, so that if something does error out we can tell. And then in here let's include lib USB. The thing about this, the thing about lib USB, lib USB dev install. In order to do this, you need to install libusb, and you're going to have to do this, something of the sort. Sudo apt install libusb dev, and then now you can include this header like this and basically use it as you wish. Okay, cool. So that enables you to do that and include. So we can go lib usb dash lib usb dash 1.0.0 dash .0 dash 0. Lib .0 lib usb. How did they say it? Lib usb.h. I think that's the one we need. So that includes libusb, and we can start using it. So the first thing we need to define is, as we saw, we needed a vendor ID. Let's look. We need to define a vendor ID and a product ID so that we can use this to actually communicate with the device itself. So ls USB. And what I want us to do is not that one, but there should be another one, a Nordic Semiconductor USB example. So this one. So we're going to use this one, and libusb is VID. So now ls USB result. So I want to know which one is the I think it's a PID, VID. I'm not so sure. So let's actually just let's make sure that the PID. So I just want to. I think it's a PID, and then this is a vendor ID. But let me just confirm. Okay. ls usb dash help dash h. So it goes vendor product. So VID product. Is that so? So if this is a vendor, dash D vendor. Okay, copy ls usb dash D. I need to know what the format of libusb is. Yeah, let's look at this. So someone needs to tell me what it is. So which one is the vendor and which one is the I am a noob. So I need to know which one is the vendor and which one is the device. Actually, we can just check in the code. We can actually check in the code here. So let's actually go into browse code on GitHub. It's fine. And then if I'm correct, we can check in prg.conf, and then PID is 0 cross 011. LSUSB. 0 cross. Yeah, okay. So this is so VID, vendor ID, PID. Cool. Now we know what the vendor ID and PID is. So let's actually define them. Define vendor ID. Vendor ID ID, and we can call this zero cross what is it, zero cross this. Okay. And then I know that's it, and then I'm gonna do define product ID, and then is it zero cross? I think it's 0001. Okay, copy, that's fine. And then I'm gonna copy there, and then we need to define the control DTR and control RTS keys as well. So define ACM as control DTR, and then this is 0 cross 01, and then define ACM control RTS, and then 0 cross 02. And then just a moment, excuse me. And I'm gonna pose for questions. Any questions? Let me check for questions. No questions so far. No questions so far. So, and then this control DTS and control DTR and RTS are actually these. Where are they? I think this something like this. And the control DTR and RTS are just keys that we're going to use. ACM control DTR. So, okay, cool. What is we can actually look at it here as ACM class. So here you go. So there are pins that we are going to be using. Control F, RTS, light phone. No. So this should be actually defined something. Yeah, the USB host controls the line control, RTS, and DTR pins, break signal, and so on of the CDC-ACM device. So whenever necessary, application is responsible for applying the line control. So these are they are basically line controls, because USB is made of two it's 4 wires. There's 2 differential ones, and I think 2, and then there's 2 other ones that are single-ended. So let's keep going. Let's actually keep going with this and see where we where we end up. So we've done that. We've defined the control DTR and RTS, and then what we want to do now is to make a global variable where we keep the device handle. Global variable device handle. Okay, cool. And then so let's put this in some struct, static struct lib. So this is from libusb device handle equals let's just h, and then let's set this to null. That's where we start. And then the next thing we need to do is to actually define a couple of endpoint addresses to know which ones we're going to be using. So let's actually find out our endpoint addresses. ls usb dash v. Oh, shame. So I kind of actually here ls usb h, let's see, encrypt positive node. Dash d 0 cross What is the device number that we're going for? Vendor ID is this. Copy. 0 cross 2 FE3. So how do I do this? Vendor that. No. Let's do dash B dash H. And let's use B for specific device. I don't want this because that's too big. Dash S 24. Dash S. Okay. So I can do ls USB. So I can do bus device number. So bus device number, and I'm going to do bus 1 device 8. Let's USB dash S. That is dash S 1 8. Okay, cool. And then I guess dash V, and then EP out, EP in, endpoint out, endpoint in. And I want to know, what do I want to know now? I would like to know EP in address and EP out address. So configuration descriptor, I want to find EP out. Abstract communications model, EP out. Capabilities, no. So this is EP1 in, and then there's EP1 in, EP2 in. So CDC data, I would like CDC, not CDC control, I would like CDC data. So this interface descriptor 10, CDC data. Episode 2, EP in is that one, EP out is 01. So these are the two that I want, EP in and EP out, these two. And because this is CDC data, because this is the interface, the CDC data interface that we want to use. So 082 is in, and 001 is out. So endpoint addresses. So I hope I can do this in 30 minutes. Static int EP out, EP in addr equals 0 cross 82. I'll come back and confirm. Static int EP out addr is equals to 0 cross 01. So let's actually just go and look at them again. So let's see. EP in 0 cross 82, yes. EP out is 0 cross 1, and I don't think there's another EP in and out. So those are the ones that we're gonna use today. That's fine. That works. So now the next thing we need to define is how to actually write to this device. So as you remember, we can write F, and it will, it writes back. So this one of those is a send and another one is a receive. So what we want to do is actually replicate this minicom thing that is happening right now, and we want to see if it works. So this application, as described here, it just echoes back. Let's see. The characters entered in the serial emulator and serial port emulator will be echoed back. So we want to be able to define a writer and a reader. And once we have the writer and the reader, we can just do stuff with them, because when we write it will send, and when we read it will read back the data that we wanted to do. So okay, cool. So the next thing we need to do, define write to device. And what the next the way this function is, I think we need to do something like sort of like fprint or something like that, because we need to send a character to the device. We just need to initiate a bulk transfer, and we need to initiate a bulk transfer in the direction of the device. So we need to, so like where was that? USB CDC. What were we looking at? USB CDC device classes. Where was USB CDC? Did I actually USB CDC class? Yeah, so I don't want to use that because this is a huge document, but it will describe exactly, so we can actually get all of it right now. But it will describe basically what I'm doing here, and I know this because I had a discussion at work, and I had to do some discovery by myself, and this is fine. And I need to, this is the agreement errata. No, I want the CDC one. I have not. Yes, so here, functional model class descriptor, ATM networking. So what I want to find out here was how to actually write to the device. Functional overview. So what I want to do is, where shall we find how to write to the device? But what we need to do is is that it? Well, I will find this and I will share this. But the way it's easier to read the code, and basically the way I know this is because I read the code. It's not because I actually know or something. I just read the code, and I'm trying to follow like a flow chart I have here. And the way we end up doing this is we end up is that Discord messages. Cool. No Discord messages at the moment. So the way we end up doing this is that we write you basically simply initiate a bulk transfer to the endpoint with the EP out address. Okay, so this we just write a bulk transfer. So there's these two endpoints that we've described here, this EP out and EP in. If we initiate a bulk transfer to the out one, it's writing, and if we initiate a bulk transfer to the in one, we're reading. So let's actually do that. Void write character, write char, and then let's take an unsigned char c, and then what we want here is what we want to do is actual int length, actual length, and then in here we want to if lib USB bulk transfer. So this is why this is actually quite easy at the moment, because you don't have to you don't have to do this yourself, because there's already stats that do this. Okay, and then we're going to go on it's the character, and then we're going to say it's the size of 1, and then the next thing we're going to pass in is the actual length, and then the next thing we're going to do is a 0, and then and we're going to do, if this is less than 0, we want to basically error out, and if not, fprintf std_err, and then is std_error while sending check. I think I can do something like this and do a D and like that and do a D because I'm used to this from Zephyr, and I can do a new line and then I can do that and then I can do that and I can say let's do int rect, and then what we want to do is go here and go like it's equals to that, and then what I want to do is here I want to do if rect is equals less than that, what I want to do is that, and yeah, I'm kind of used to this pattern now from Zephyr, so that we kind of know what we are doing, and then we can do that. This is how you can end up writing USB applications without actually needing to be very knowledgeable as to how they work, because the thing is, once you can start and once you understand kind of on a high level how it works and where it's going, then it's quite easy to build up, and you can do stuff. So let's actually make define read from device. I'm rushing a lot today. I'm not explaining because I have to leave in quite a little while. Read chars, and then I want to do unsigned char, but this is going to be some an array of some sort and size, and then I'll say how much I want to read, and then what I want to do is so in order to read, we need to initiate a bulk transfer with the endpoint labeled endpoint in. Okay, so actual length, so it's kind of the opposite of what we did up there, but int rc is equals to lib USB bulk transfer. So basically the thing that happens is, because you have libusb, you don't really have to write a lot of specific USB code. We can just build a normal C application, and the normal C application can actually do what we want. I think this is going to be a timeout of some sort. And then once we can see something working, it's quite easy to now start figuring out the deeper parts, because USB is a really USB is a really huge kind of ecosystem, and if you had to actually discover it all the way, like the way we do drivers, even including the way we do like image sensor drivers, which are actually quite huge, it would be quite tasking. So it's quite easy to find an inroad somewhere, like some way of getting into it, so that you can kind of understand what is actually. And then I think that's that. So timeout, and the length is printed there, and then we need to return some sort of error. This is going to be an early return of some sort, and then the next thing we need to do is so let's do an else if rc is less than 0. This is also an error. What do we want to do here? If this happens, what do we want to do if that happens? If rc is less than 0, we need to sort of report the error. Yeah. std error. std error. No. Print f std error. USB. This is oh, no, actually we're not doing initialization yet, so error while waiting for characters. No, yeah, error while waiting for char. And then here we want to do new line, and then after this we need to go that, and we know this is some sort of error number, and then we want to return actual length. Okay, cool. So there's that. Okay, cool. Gonna take a drink of water. If anyone has any questions, please feel free to interrupt me, and I can always stop. Let me actually check for questions. Hi from Tamil Nadu. Hi Lana123. Hi from Mumbai, from the Tasteful Thickness. I cannot believe you just made me say that on stream. But hey, let's keep going. So now let's actually make our actual application. Int main args. I usually respond quite a lot faster, but today I'm like I'm in a hurry, so I just want to I know a lot of people end up believing that I'm not doing a live stream because it's like a recorded one, but sometimes when I rush I don't check the stuff, but I will check them again. Yeah, so I saw the two of you and I saw the comments, and I say okay, let me put this. Hi everyone. Struggling to do all the content. Please allow for slow responses. Okay, thank you. Please allow for me. I can also do. Can I do this? Can I do this? Can I do something of? Yeah, so let's do that. Let's pull this out. Just a moment. Let's pull this in here to somewhere like here, and then can I pop out the chart? Pop out chart, pop out chart, pop chart out, pop out chart, and then I can put chart here. Yeah, so people can actually see themselves chatting. Yeah. That way, you know you're live. That way I can always see any questions. Okay, so I can see any questions and I can keep going. Okay, cool. And if you want to see your name pop out in the chat, just put it up, and obviously it'll show up there. So let's actually keep going here. What we want to do is we want to now use the functions that we've already defined. Okay, so let's now initialize it libusb now. Finally, remember we already have a library that does it, so we don't need to do any libusb init, and then we can do null, and then let's do that, and then if rc is less than 0, let's actually throw an error, and then we can do f print f, and in here we can do stdr, and then we can do error initializing libusb, and then we can do this. Let's take what happened, and then let's do a new line, and then in here let's actually libusb error name, and then rc, and then that, and then I think that, and we can do an exit one. So let's actually just exit out of the program. leave that out. And then the next thing we need to do is to actually now that we've done that, let's actually set debugging to max. Set max debugging, so that we can see any like anything that set debug now 3, so that we can see if any error occurs when we're trying to communicate with this device, we can actually see it. Okay, so now let's actually try and talk to a device. Let's look for the device. Find the device. We need to find the device. It's gonna div h, because this is a struct that's already been found. Lib USB open device. Okay, sorry. Device with VID PID. Remember VID PID, and we already defined these ones up there. So we're gonna do it now, and then we're gonna do vendor ID. Vendor ID and product ID, and then no one's asking questions yet, so let's keep going. And then if this is null, we need to go like, whoa, there's no device. We need to do that. fprintf, and then stdr. Error finding USB device, and then let's give it a new line there, so it's sort of neat if something happens, and it doesn't arrest our fprintf here. It doesn't arrest our terminal. I only have like less than 15 minutes. Go to out. This is a label we will describe somewhere later. So now, because we're dealing with a CDC-ACM device, and Linux usually attaches the device already attaches the driver to this device, we need to sort of detach this driver so that it's not there, so that we can actually use our own program to, fetch the device. So we need to detach the drivers from the USB interfaces, and then the CSV class defines two interfaces, the control and the data interface. So we need to detach those of them. And remember these interfaces that we just saw here. I think we just saw this one. So there's an interface descriptor here. This is CDC data, and then there's also going to be an interface another interface descriptor, and this is communications abstract. So you see, there's two. There's a CDC and an ACM devices. So we need to detach the device from it. So 4, and then because it's two of them, 4 int interface num is equals 0, and then interface number is less than 2, and then interface number num equals to plus plus. So let's just go iterate through them and actually detach them. If lib USB kernel driver active dev h, and then if num, and then let's do that. If it is actually active, we need to do a detach with USB detach kernel driver dev h num, and then there's that, and then let's do that, and then let's close this, and then the next one we need to do, check the return for that, the return of libusb, what does it want to claim interface dev h if none. So what are we doing here? We are, for each of the interfaces that are they are defined, we are detaching them from the kernel driver, and then we're using this program that we're building to actually attach to it, and we're checking that the attachment is correct, actually works. Okay, so 0. Okay, so after we do that, we can do this, and then we can go fprintf, and then we can do stdr, and if actually something wrong, we go like error attaching, error claiming interface and then here we're going to do libusb error name, and then here we're going to put offer rc as the error. Actually no, that's actually gonna be that, and then that, and then after this, if something goes wrong there, we want to go to out, and then we want to close that, and then we want to close that. So we've now claimed both of the interfaces, and what we next want to do is now we want to start configuring the device. I don't know that I'll manage to finish this one today, because I have this weird obsession with actually writing all the code. I could have copied it over, but it's fine. libusb control transfer, and then dev h, and then in here we want to set 0 cross 21, 0 cross 22, 0 cross 22, and then and then that, and then ACM control DTR, and then OR that with ACM control RTS. Isn't it? And then after that we want to do a 0, and then a null, and then a 0, and then usually the way I do these streams, I try and be very verbose, and I go through these functions, and I try and like we read the function before we use it, but I'm trying to do it every day now, and sometimes you just don't get the time. Unsigned char encoding, and then this is going to be this, and then it's going to be that, and then now we're going to do some 0 cross 80, 0 cross 80, 0 cross 25. This is, you don't have to memorize all of this, okay? And ideally, to be honest, cross 25, you don't have to memorize all of this, and 0 cross 0. I'm just looking at my notes from earlier and doing it from there. So I don't want anyone watching this to feel like you have to like be magical and know all of this, but it helps if you end up knowing it. But so 1 2 3 4, 1 2 3 4, yeah, it helps if you know it, but you don't have to know it, and it's just comfortable. And the only way you're going to know it is by like looking it up the first time you do it. libusb, then what do we want to do here? Control frame transfer in here, and then we're going to do dev control transfer. Let's do that. Dev h, and then encoding, we want to do size of encoding. And then 0. Okay, and then that actually concludes us sending the control transfer. So now we want to RC is equals to less than 0. If the response there is less than 0, we're going to now actually printf and in here we're going to do stdr, and then we're going to be error during control transfer. And then we want to get the name of the error, and then we're going to say new line, and then we're going to go that way, and I think this needs a comma here, and then we're going to go leave USB error name, and then this is going to be RC. Yo, I've typed so much. My shoulder is tired. From typing. Wait, why isn't that actually working? So I need to do that, and then I need to go here, and then I can go cool. So now we've configured the device. Now we can start sending and receiving data from the device. And basically what we want to do is some sort of like echo thing, where whenever we write something, we just, that's the thing we unsign character buffer, and then this is going to have let's be like arbitrary and say 65, and say so we can send, I think, letters int len, and then let's leave that, and then in here while one, okay, cool, sure. Not 2, which would still work, right char, and then the char one right is G, that's fine, and then there's this, and then the next thing we need to do is len equals read chars buff, read chars into buff 0, okay, and then buff len equals 0, and then printf std out received saved received, and then we want to go there's that, and then we're gonna go it's a string, well, new line, it's a string, and then so I want to go that, and I want to go that, and then after that, well, not really, I don't want this one here, and then after this I want to go that way, that, and then new character, and then close that buffer out. Yeah, so there's that, like that, and then and then buff, and then we have, after we do that, we're going to sleep one, okay, cool, and then there's that, and then we need to define that label, lead USB release, in case we have this interface dev h0, and there's that, and then we want to come back here and define an out, and then if dev h lib USB close, close dev h. Okay, so we want to close them, and then lib usb exit with a null, and then there's that, and then return rc finally. And that is it. Genuinely. Control Shift T. And then I think, if I remember correctly, we need to go and find out how to actually we need to do how to link Control R dash L. Yeah, something like this. GCC no. Tab. Yeah. Whoa. Okay, cool. So let's fix this. If internet lib ls lib usb bulk transfer. So number 33. 33J. Oh. Okay. So that, let's do that. Let's build it again. Ah, okay. Now I see. And then this is bulk transfer. Okay, then let's build it again. They're gonna get fewer and fewer, and then suddenly they're gonna be not there. Oh, they're getting fewer and fewer. 51. I think this is where there's an issue here, and then they're gonna get fewer and fewer, and then suddenly there won't be any issues. Ooh, they went more. What didn't I write? Oh, there's a return here we're needing. Okay, fewer and fewer, and then suddenly there won't be any. Why is this? Why does this keep erroring out? Does anyone see the issue here? errors as we can, so that we can actually, oh, yes. There you go. There you go. So it's sort of working. I don't know why it's stopping, but it is sort of working. It worked. We made it. We made a thing. So let's actually see why it's not printing the thing we wanted to print. SDR received S buff. Okay, cool. So why don't we try this actual command in here, control A. How do I exit? X. Yes. Document eng just one moment, I'm almost done. ls sudo can I do just a out? Okay, control A, sudo a out. So there's an error, obviously. Error while waiting for character. Error. There's a libusb error pipe. Error during control transfer. Let's see. There is an error. So let me actually just commit this code, and then we'll come back to this later. That has been insanely impressive. Git status. Git add. Git init. Okay. And then let's go make a new a new thing. GitHub.com. I have to stop now. Thank you so much for everyone that came to this session. I have to stop now, and I'll have to see you guys later. Yeah, so thank you so much for everyone who came to this session. I'll have to stop now, and then I'll have to come by later, and then we'll have to actually fix this later. We might actually end up fixing this later today, but we will see. And I do not know. I think it's quite, my CDC host, git commit. Don't push the door. Sample CDC. Sample CDC application. Sample CDC application. Sample CDC application. Broken pipe comment. So yeah, there we go. We've made and I'm gonna do a git push. Let's set upstream to master. No. Okay, that has been pushed and it's available on this repository. So Zach libusb cdc host example, And thank you everyone for coming up to today's thing. And that was a really good on fire experiment. We almost got it. This is now debuggable. Once we start debugging this and trying to see how it works, it's going to be quite easy because we're going to go into the functions and understand what means, where it means, where it comes from, and everything. As always, thank you so much. And you can support me by sponsoring me or doing a subscribe or a like on the video. And thank you so much. Cheers. See you guys and ladies another time. Thank you.